Some of the ideas of the remainder theorem, which was clear was not fully mastered yet from the Unit 1 test. So the remainder theorem says, if a polynomial, f of x, is divided by x minus a, then the remainder that you get is the same thing you would get if you plug in a to the function, right, is f of a. So for example, if we're given this polynomial function p of x, and so you see what is the remainder if p of x is divided by x minus 4? Using synthetic or long division, we can say that the remainder, after you do the whole thing out, is 6. Okay, that means if we were to plug 4, right, x minus 4, x minus a, so if you plug in a into the function 3x squared minus 16x cubed plus 15x squared, that whole thing, p of x, you'll get 6, the same as the remainder when you divide. Right? That's what the remainder theorem says. Same thing if you're dividing by x plus 3, right? So then our synthetic division, we put a minus 3, we end up with a remainder of 5. That means p of negative 3 equals 5, because that's what the remainder theorem says. When you plug into the function, you would get the same thing as the remainder, as dividing by that factor. So here was question 13 from the test. Only about a quarter of you got it correct, so take a look at it now. Based on the table and the remainder theorem, which of the following must be a factor of p of x? So the fact that it's a factor tells us that the remainder has to equal, that says remainder equals 0, right? So if the remainder is 0, that means p of x, whatever we plug in for x, has to equal 0 at that point. So we're looking on the table, where does p of x equal 0? And it actually occurs twice, at negative 5 and at 2. So that means that the factor x plus 5 must be a factor of p of x. And so does x minus 2. So there's 2 correct answers here. But if you look at the answer choices, x plus 5 isn't a choice. Only x minus 2 is. So that would be your answer. And again, we know x minus 2 is a factor because the value when you plug in 2 of p of x is 0. And that means the remainder when you divide by x minus 2 would be 0, making it a factor. Okay, question 14. Determine the remainder, if possible, of p of x over x plus 3. Now, we don't know what p of x, the actual function is. We can't divide it. But we do have this table that gives us x and p of x. Now, the remainder theorem tells us that p of x divided by x plus 3, the remainder is going to be exactly the same value as p of negative 3. So we have to look at the table where x equals negative 3, and that is our answer, 25, because that's p of negative 3. Okay. So go ahead and try the check your understanding problems on Delta Math. Hopefully it makes more sense now. Thanks. Please reach out if you need anything.